Hello. So today we are going to be talking more about inequalities. In the previous video, we talked about the symbols and how to interpret each of them. However, today we are going to actually be talking about solving inequalities. So let's go ahead and do two examples here to start. 2x plus 1 equals 6, and we'll do 2x plus 1 is greater than 6. So these two expressions are essentially identical on the left and on the right of our two symbols here, the equal sign and the greater than sign. And of course, the only thing being different is that symbol in of itself. Now, remember, these symbols, the equal sign and the greater than sign, are both showing or indicating a relationship between the things on the left and what is on the right of each of the symbols. For instance, this left expression says that 2x plus 1 is the same as 6. Over here we have 2x plus 1 is greater than 6. Either way, this x is a missing term that we want to figure out. What value of x, what numbers, in this case, are going to make this statement true, and what numbers x are going to be making this statement true. So what we have done typically is, well, I want to get x by itself. I want to figure out what value of x is going to be the one to look for in order to make this true. I want to get x by itself so I can read, well, x is blank. So in order to do this, I'm going to go ahead and move this down here a bit. I say, okay, I'm going to take 2 times my number, and then I'm going to add 1 to it. I get 6. Well, the end goal here is to get x by itself, so I'm going to get rid of all this fluff around x. I'm going to start by taking away this 1. Because look, 1 minus 1, that is 0. We are left with 2x. Over here, 6 minus 1, well, that is 5. Perhaps I should have chosen a different example, ha ha ha. And you'll see why, because look, right now I have 2x equals 5. I want to get x by itself down here. Well, I need to get rid of this 2, which is multiplied against the x. So to get rid of multiplication, undo multiplication, I divide by 2. And I'm left with, well, x, well, these guys cancel out, and I'm left with x is equal to 5 over 2, or 2.5, if you will. Over here, on the right, we're going to say, okay, 2 times some number, if I add 1, it's going to be greater than 6. Now, if you think about a number line, there is going to be some number, let's say it's like right here, after which it is always going to be true that this expression is greater than 6. We are going to look for this number here. Now remember, when we were talking in the previous video, this number right here, whatever this is, if you think about like the expression greater than or equal to, this number is the equal to piece. Well, what does that mean? It means I can solve my equation or solve this expression or this statement right here for this variable x, treating it as though it was an equation, and then I can look at everything that's beyond this little line here. So let's go ahead and imagine for a second that we're dealing with an equation. How would we solve it? Well, exactly like we would over here, because the numbers would be the same. So let's go ahead and write back in our equality here. I think is greater than 6. If I can subtract 1 to cancel this guy out, subtract 1, we were left with 2x is greater than 5. And so if we divide by 2, we wind up at x is greater than 5 halves. And so you imagine on our number line, this number right here that has this all these crazy little marks by me, this is precisely 5 over 2. Which, if you think about it, number line 0 should be somewhere to the left of it. Imagine 5 is somewhere over here. I'm just writing that because there's a 5 divided by 2 right there. And yeah. So here, we solve our inequality the same way, and then we just interpret, okay, everything to the right of this magical number is going to be a solution. And again, we leave a little circle here because we were just dealing with strictly greater than, not equal to. However, the equal to is very useful for figuring out where our arrow should start. Now I will say if this was, for instance, less than, we'd solve it the exact same way. However, our answer would then be pointing to the left. If it was greater than less than, imagine I'll switch these symbols with it as well. If it was less than or equal to, then we would fill in the circle because we are including this as our answer, 5/2. And of course, if we had less than or equal to, we would just make the arrow go the other way instead. But I'm not going to include that because it might make it messy. And so we have now looked at solving an expression. Sometimes we call these multi-step expression or inequalities or multi-step equations because we do, for instance, one, two, more than one step in solving and getting our final answer. And yeah,